I am going to talk to you today about compound interest. And warning, it's been a little while since I've made a video, so this could be a little rough, but bear with me if you would, please. Okay, I've got a simple example for you of the difference between simple and compound interest. I do hear a couple of snickers, yes? All right, so I've got this example worth an initial investment of $1,000, and I'm going to earn 10% interest. And no, no one gives 10% interest anymore, but we're going to pretend for the moment. In my first year, I am going to earn $100 in interest, right? At 10%, I'm going to earn $100 in interest. And then in year two, I will still earn 10% interest, so another $100 I've earned in interest. So over that 2-year period, I've earned $200 in interest. So taking the principal amount I invested, the $1,000, adding my $200 in interest, I end up with $1,200. Cool. Say it's the same thing, but let's talk about compound interest. I take that same $1,000 and now I've got an interest rate of 10% still, but after that first year when I earned my $100 in interest, that money goes back into the pot to then earn 10% on. So that extra $100 is earning 10% interest. So now that second year, I've earned $110 in interest for a total in 2 years of $210. So my new amount that I've earned in 2 years is now $1,210. Not huge, but I have an additional $10 there from our compound interest. Okay, so we're going to talk about compound interest today, and this is our basic formula. This is the amount I'm going to have at the end of this period of time that I'm investing my money. This P, of course, stands for the principal or initial amount that I'm investing. And the 1 plus our growth rate. Obviously, this is growth because it's going to be a number greater than 1. So this is our B value, right? And I'm raising it to the T for my time period. Okay, so in that example that I had, sorry, told you I was rusty. That's going to be A equals P, my principal amount of $1,000. And my interest rate, remember, is 10%. So I'm going to earn back that initial 1,000. So I need that 1 there. Plus my additional 10%. There's my B value. And I'm going to raise it to the 2. And grab out your calculators real fast. And make sure that, in fact, you got $1,210. Okay, so here's all of the pieces, parts that I just told you about. And take a second to make sure those are all in your notes. So here's our next example. Lindsay deposited $1,000 into a savings account. She earned 6% interest compounded annually. How much money is she going to have after 5 years? And I want you, of course, to round to the nearest cent because that's all we have. So take a second and figure out how much money Lindsay's going to have. Remember, our equation is going to be what the amount of money we're going to have in the end is the initial deposit, my P, times my growth rate of 1, it's 6%, so I'm going to write that as 0.06. And it's going to be a period of 5 years, so that's my time period. And when I plug that into my calculator, I find that Lindsay will have $1,338.23 at the end of 5 years. All right. We've got another example. Thomas is saving for college. He wants to go to A&M apparently. And he's going to put $3,500 into a savings account that will earn him 4.5% interest compounded annually for the next 10 years. How much money is Thomas going to have to attend A&M in 10 years? So go ahead and pause the video for a minute and calculate how much Thomas is going to have at the end of 10 years. So again, our equation, we had our principal amount, our growth rate, time period, and we'll see that Thomas has $5,435.39. So that's pretty cool. Thomas is earning almost $2,000 on that money. But let's see how Thomas might be able to earn a little bit more money. So most savings institutions have compounding intervals that aren't just annually. That means they compound your money. They put that interest back into your account in periods shorter than one whole year. For example, it's very common to have quarterly compounding. Quarterly compounding, or which would be the end of every 3 months. We could have monthly compounding or even daily compounding. And those are the examples that we're going to look at today. So, how are we going to do that? Well, if a bank advertises that it offers 8% interest and it's compounded quarterly, that means 4 times per year I'm getting my interest on my interest that I've already earned. So 8% is not what I'm earning per quarter, but for the entire year. So I need to determine that interest as a quarterly number. Well, of course, I'm going to take my 8% and divide it by 4 for 4 quarters, which means every quarter I'm effectively earning 2% interest. So let's try that out. My quarterly interest rate for an account that's earning 5% would be how much on a quarterly basis? Well, that's going to be 5% divided by 4, my quarters. So that's 1.25%. If Madison invests $10,000 in an account that earns 5% interest quarterly, I want to write the function that will represent Madison's balance at the end of T years. Well, how do I do that? Well, I want to know how much she's going to have at T years. She will have her initial investment of $10,000. Her growth rate, remember, it's going to be 5%, but that 5% is quarterly, so her growth rate is actually going to be 1.0125. Sorry about that. Here's my quarterly growth rate. But then if I'm going to do this for 5 years, I need to account for the fact that it's in quarters. So I'm going to add that 4 back to tell me that it's happening 4 times per year. So it's happening over 5 years. Did I tell you it was 5 years? Nope. Let's make it 5 years. So we're going to have Madison's money in her account for 5 years. And during that 5 years, it's going to compound 4 times per year. So how much money is Madison going to have? Grab out your calculators, calculate very quickly. Okay, I got $12,820.37. Pretty cool. After 5 years, I have earned over. So let's go through and calculate what those functions are going to look like for different time periods. So we would like to write a function. We're still using Madison's account of $10,000. We're going to now put our money in for 20 years at 5% annual. So we do have 5% annual compound interest, but we're going to have different compounding periods. Sorry, I had my coffee break. All right, so yearly, what is that going to mean? Well, it's exactly how we've had it before. And I apologize, guys. For some reason, my computer is not reading an exponent. So that little arrow is telling you that that t is supposed to be an exponent. So I've got my initial interest, and because it's just once in a year, I've got that full 5% raised to the t, or 1t, remember, because there's no number in front. So I've got that one time. Quarterly, I'm going to have my $10,000, and we just went through this example. It's 1.25% for 4 periods, and I have to account for 4 periods over the amount of time we're investing it. And in a minute, we'll go back and figure out that 20 years. Monthly, well, I would have to divide that 5% by 12. So I'm going to get an interest rate, and yes, guys, I'm going to have to go out pretty far. Otherwise, if I'm rounding too much, I'm not going to get the difference in the amount of money. So that $10,000 is going to get compounded monthly, which means my interest is 0.417%. So raised to the time period of 20 years in our case, but I've got to multiply that by 12 in order to figure out what that's going to be. And finally, I'm going to do that daily. And daily, of course, I'm going to divide my interest rate of 5% by 365. So that amount is now going to be, let me see, 0.0137, and remember it's going to be 365 time periods. So here's my function, 10,000, there's my interest rate, and 365 periods over that 20 years. So let's go ahead and figure out what that's going to be. Pause your video for a second and let's see what that 10,000 is going to be in 20 years compounded daily. Not bad. I'm going to have $27,183.67. Pretty cool. Okay, so this time I would like you to write the compound interest function for a $1,200 initial investment, and the interest rate is 2% compounded quarterly over a period of 8 years. Write the function and then calculate the amount. You are probably going to need to pause the video here for a minute. Okay, so my 2% interest, which believe it or not is still a really high interest rate in these days, over a quarterly period is an effective rate of 0.005. So I'm going to write that into my compound interest formula. Remember, I've got the 8 years that I'm looking for, and I'm going to have to multiply that by 4 because of my quarterly periods. So I'm going to end up with $1,407.65. I'm going to totally let you run with this one. Pause the video, $10,000, 5% compounded monthly for 4 years, and check back for the answer. Okay, so we compounded monthly, so we divided by 12. There's our 12 to account for all those periods, and I've got $12,210.90. So we are going to do a little bit of mixed review, going back and looking at all of our decay and growth exponential functions. So get ready for a few exponential growth and decay problems. Your first two, pause the video and figure these guys out. Go. So we have an example of exponential growth here. We have our initial 1440 employees and our growth rate here, our B of 1.015 over 9 time periods, 9 years. So we've got 1646 employees. Remember, guys, I better not see a decimal there. I do not want pieces, parts of people. In our second example, we went back to our compound interest and we used a quarterly interest rate. or quarterly compounding. I'm so sorry. Here's my function, and we're going to end up with $29,318.64. And I've got 3 more review problems for you. Okay, we've got another interest problem. We've got this one, guys, is going to be a exponential decay because we're decreasing our population by 2% per year. Careful with your B on that one. And then I've got a half-life. So if you don't remember how to do half-lives, chat with your neighbors. Look at your time periods, okay? All right, pause the video and come back and check on answers. Okay, so in this one, remember we just went back to an annual compounding situation. So here's our answer, $640.04. This second one, I had a exponential decay. So remember my B has to be less than 1. So accounting for my 2% decrease, I now use a decay rate of 0.98. So I've got 1,706 deer. Again, I don't want pieces, parts of deer. That's just as bad as people. And in my third example, I had a half-life of 8 days. So I had to take the 40 days that I'm waiting, divide that by 8 days, remember, to figure out how many half-lives I've got. That's my time period, 5. So I've got my function f of t, and in this case it's going to be 5 time periods. My initial population of 30 grams. It's a half-life, so I've got 0.5 as my decay rate, and I've got 5 of those half-lives because of those 8-day half-life periods, giving me 0.9375 grams of iodine left after 40 days. All right, so for homework, you are going to be working on a worksheet on compound interest. You have an IXL assignment. Keep in mind on the IXL assignment that it sometimes asks you to give the entire amount you will have at the end of the period, in which case you just use the formula that we've been practicing. But sometimes it asks you how much interest you're going to have earned over that period. So you'll need to go back and subtract the principal amount. So be careful when you're answering that you look to see what it's asking for. Just the amount of interest you've earned or the entire amount in the account at the end of the period. And sorry to have missed you guys today, but I will see you on Monday.